Hi, this is Kim, and here is my video answer to problem set number 1, question number 5. Okay, in this problem, we are told that a researcher conducts an experiment with 30 rats. 10 are assigned to condition A, 10 to condition B, and 10 to C. Now, the twist is that all of these rats are cloned from the same source. We're asked to explain why the clone experiment would be superior to both between subjects and within subject studies that utilize non-clones. Okay, first of all, let's get something straight. Rats are gross. Mice, on the other hand, are cute, and so I'm going to be using mice in my example. And let's invent an experiment for this question. So one problem that might be common to mice is timidity. So let's design an experiment that evaluates the effectiveness of different assertiveness training activities for mice. Okay, so the first part of question 5 asks us to consider a between subjects design. Now, this is a design that uses different groups of individuals for each condition or levels of our independent variable. We're talking about assertiveness training activities for mice, so that's going to make the activities themselves our independent variable. And so this is what our groups would look like. We're going to have one group of mice that we're going to assign to condition A, and we're going to let them engage in 1 hour of activities that are common to mousehood. This could kind of function as our control group. One group of mice are going to get assigned to condition B, and we're going to let them engage in 1 hour of mixed martial arts training. And the group of mice that are lucky enough to get assigned to condition C will engage in 1 hour of heavy metal singing. Then we'll come up with some nifty measure of mouse assertiveness and use it to test each of our groups so we compare the effects of our various conditions. Okay, so how would using clones for these groups be better than going out and getting 30 regular old mice? I mean, times are kind of tough, and I'm sure there are hardworking research mice out there who might be able to use the work, so why not hire them? Well, we could. But there's an awful lot we don't know about these mice. Maybe some are just more naturally aggressive than others. Maybe some come to the experiment with some skills or some kind of experiences that make the condition they get assigned to more or less effective. Maybe some are bigger, some are smaller, some are older. I mean, who knows? All of these mice are different as individuals. And those differences, those individual differences, can really add up in a between subjects design. It's going to make it very hard for us to know if the results we get in our experiment are caused by the differences between our treatment conditions or simply the differences between the groups themselves. Now, this can be a problem in between subjects design, and here is where our clone friends can come in. All of these mice are from the same genetic stock, so we can theoretically eliminate any biological differences. And all were raised in the same environment, so we can theoretically eliminate any experiential differences. So using clones for our 3 groups gives us nearly identical individuals in every condition. So our groups are about as similar as we can possibly make them. This gives us the most level playing field on which to compare our different assertiveness training treatments. Ah, but you say, wouldn't random assignments solve this issue for us if we use the non-clones? Couldn't we just randomly assign the non-clone mice to each of the conditions and then have all those individual differences be spread out evenly throughout all the groups? Well, sure, and that's how this issue is normally dealt with in a between subjects design. But we're still dealing with chance, and doing it this way won't eliminate individual differences. It's in our best interest to have as few individual differences as possible, so I'm going to call this one for the clones. Okay, now another way to get around individual differences is to use a within subjects design. And in this setup, we're going to utilize just one group of participants. But this handful of participants are going to experience each of the treatment conditions, effectively creating 3 groups that are identical except for the independent variable. Now, it sounds great, right? Well, unfortunately, this design comes with some of its own problems. Let's go back to our soon-to-be more assertive mice. Okay, to set up our non-clone within subjects design for this, we'll take 10 regular old mice, and then we'll run them through each of our conditions. The treadmill condition, the treadmill running, the mixed martial arts training, and the heavy metal singing, and we're going to measure them after each of those conditions to compare. But if our goal is to compare the effectiveness of each condition, we're going to have issues with this approach. What if one of our conditions changes the mice? What if our mixed martial arts treatment is super effective and it raises the assertiveness of our mice. Or maybe the mixed martial arts condition makes them really tired, and then they do lousy on the next condition, which is the heavy metal singing. If all of the mice experience the martial arts condition before the heavy metal condition, any measurement we get from the heavy metal condition is going to be pointless. The heavy metal singing score will include effects from the mixed martial arts training. Right? These are examples of order effects. And this is where where experience with one condition affects performance in a subsequent condition. Okay, now to get around these, we can go through all manner of counterbalancing contortions, and in fact, that's what's normally done. But in our case, we could just use the clones again. We could put 10 clones in each condition, and we get all of the participant consistencies that we'd have in a within subjects design, because the clones are identical, but we don't have to deal with order effects, because no mouse experiences more than one condition. So, bottom line, clones make science easier. Ish. Well, okay, not really, but it made for a fun problem. All right, that's it. I'm done. I hope you enjoyed watching this. I enjoyed making it. See you next time.